Let's talk about correlation and regression. One of the big things that you want to know about statistics is that even though I'm going to talk about correlation and how that makes things relate to each other, you hear the phrase a lot, correlation is not causation. So this does not equal causation. Correlation just means two things have a relationship. Causation means one thing causes the other thing. So let's talk about some relationships. We've already talked about one relationship, and it was the function relationship. Here's one function example. You had a particular input, and that gave you an output. And we had the independent variable and the dependent variable, so I'm building off of that. There's also exponential. I mean, we have all sorts of functions. We had exponential functions, logarithmic functions. We even had the quadratic functions. These are all sorts of functions. They all had different graphs. I did pick this mx plus b for a reason. For correlation and regression, I'm going to be talking about straight line linear modeling. That's what this section's dealing with. So we're only looking for things that have a straight line type of relationship. So when I talk about correlation and say things don't have a relationship, I'm not meaning they might not have some relationship. I'm saying in particular they don't have a straight line kind of relationship. So we have this idea that we've got x's and y's, and for each x value there's a particular y value, and we map them all together and we create this relationship between them. So you have a formula for correlation, and it's rather intense. There's a whole bunch of x's and y's and getting summed up. Again, you're going to want to look through and work through one of the examples to make sure that as you try to calculate it out, you're able to get the same answer that the book does in an example, because it's really easy to mess up a parenthesis or something. I want to just explain what it means. We're doing this linear model, and when you get your correlation number, what it gives you is it gives you a number in between -1 and 1. That's what correlations give you. And if we grab something somewhere in the middle here, these things, when it spits out numbers in between, let's say -0.5 and 0.5, these things are things that are not related. And again, I don't mean not related for any place. I mean they're not related in the sense of a linear relationship. And if we get these things on the outside, these things do have a relationship. The closer you get to positive or -1, there is a relationship. This one on this side would be called a negative correlation, and this would be called a positive correlation. And here's what I mean by those two words. Things that have a negative relationship. As taxes increase, my happy decreases. I say these guys have a negative relationship. As taxes decrease, my happiness increases. This is what a negative relationship means. It means as one's increasing, the other's decreasing, or as one's decreasing, the other's increasing. We have this opposite relationship. On the other hand, for positive correlation, I've got maybe my salary. As my salary increases, my happiness increases. If my salary were to decrease, my happiness would decrease as well. These are both examples of positive. Even though here we're talking about decreasing, it's still positive because they're both decreasing together. You know, it's bad if you go down by yourself, but if you can drag a friend down with you, then it makes it all okay. Man, I might be morally bankrupt with that advice. But anyway, they're still both positively correlated because they're going down together. Again, when you're working through the correlation equation, don't panic when you see it. Make sure you work through an example to get a feel for what's going on. Once you've found that things are actually correlated because they're on the far side, they're very close to plus or minus 1, and they're avoiding that middle area, then you might want to do and calculate what's called a regression line. And a regression line is just going to be a function. It's going to be a straight line function because we're talking about linear modeling. And to make this calculation work, you have to calculate m and b based on a long list of x and y values that have been recorded down. You're going to plug those. There's a formula for m, there's a formula for b. You're going to calculate those out. And all this does is it lets you predict, because you can put an input x in, and it's going to calculate for you the expected output for that relationship. And so this tries to just explain what that relationship is as a formula. And so then you can make predictions. I know that if I run 1 mile, I burn so many calories. If I run 2 miles, I burn some more calories. So I could create a relationship between number of miles I run and my weight. And then I might predict that if I increase the number of miles I've run, that my weight was going down. And that would, again, be an example of calculating something that has a negative, because as running increases, weight would have been decreasing. Again, correlation regression, I've got a couple examples of those for you to work. All it's doing is figuring out a way for you to predict, based on a certain input, what's the expected output. And this is only going to make sense when the correlation is strong enough, which means when we have our dotted lines, these things look close enough to a straight line if I was trying to connect the dots. If you have things that aren't very related to each other in a correlation sort of way, it would just look like a whole bunch of mess of things. It might have, maybe this has more of a parabola shape or something to it, so there might be some relationship. There just isn't a straight line relationship going on between these random dots.